Hi, this is Mike Cobbett. I'm team lead for the IBM project team that is part of the Galasa project, an open mainframe project. Today I'm going to talk about the Galasa command line tool. So about the agenda, I'm going to talk about the tool itself and why you'd use it, what it can do. Then we're going to prepare our system for downloading and installing the tool. Then we're going to install it, initialize our local environment so we can do some Galasa tests and create them. We'll get the tool to create Galasa tests, and then we'll build them and run the tests locally and look at the results. All of that is going to take some time, so sit comfortably and enjoy the ride. So firstly, what is the Galasa control tool? Well, it's the command line interface. It's a standalone tool. The command line interface to the Galasa ecosystem and to local Galasa functionality. You can download it and you can launch it in seconds. I'll show you how to do that in a bit. And it helps you set the environment up for developing and running Galasa tests. You can get it to generate sample Galasa test code with your names and labels, and then mutate and evolve the code from there. So it provides a good starting point for writing Galasa tests. And you can run Galasa tests locally within the local JVM on your own local machine. You can put the tool into a build pipeline, and you can use it to inquire about the ecosystem. You can use the command line to launch tests within the ecosystem. You can configure the ecosystem to have configuration properties needed by the tests and by the Galasa managers and by the ecosystem itself. So it helps to administer the system, and you can find out about tests that have run in the past, find out what their status was, and download saved artifacts that they wish to save for posterity, for diagnosis, and loads more things. Okay, so now we're going to prepare my system, which hasn't got Galasa control on it yet, for using the command line tool. So firstly, let's create a folder where I'm going to put the tool, and I want to check that I've got Java installed, and I should have a command line environment variable called Java home. So that's where my Java is, and I should be able to ls-l Java home bin Java, just to make sure it's there. And if I run that one, so I'll just run that Java version just to make sure it's the same as what I think is installed, which it is. Okay, so Java looks to be good. Now I'll check Maven. So that's the version of Maven I've got, 386, which is good. Now I'll check Gradle. We use Maven or Gradle to build test cases, and the Java must be version 11, not 17 or lower than 11. So Gradle 6.9 is great, and I will just now check that my tools folder that I created is on the path. So as I'm using Zsha, I'm going to go and edit my Z profile and just make sure that I've got something on the path. My tools folder looks like it's in that file, which is good. So let's invoke the my Z profile to make it take effect. Z profile, and my profile does a number of things, but one of them is going to be setting the path. So if I echo the path, and I can see at the back here that I've got my tools folder on the path, so that's good. We're all set up. So let's look at downloading and installing the Galasa tool itself. Let's search for the Galasa dev documentation. Always a good place to start for any of this stuff. I won't be showing you anything that's not already in the docs. So if you refer to the docs and just walk through them, you should get to the same point we're going to take you to in the video. So in the docs you can see the various combinations of architecture and operating systems that galasactl supports, and we'll find all those on the download site, which is here. That's the same as if we're in Galasa dev GitHub. Here's the CLI project and here's the releases, and this is where the releases of those binaries are. Now there's quite a large selection. You can see some of them are Linux, some of them are Darwin. Darwin is the core of macOS, and there's only one Windows variant there. So if I go back to the command line, I might be unsure as to what to use. Well, uname-s says the operating system I'm using, so that's Darwin, which means a Mac, the Mac variant. And if I do uname-m, it tells me which CPU I've got on my local system. This is an M1 Mac, so I've got ARM64 architecture. So this is the one I want to download. So let's download that into my tools folder. Done. So I'll go into tools and it's there, and let's move it, rename it to galasactl. So I'll give it execute permission, so I can in theory execute it, and I need to tell the operating system to unquarantine this file. So when you download things, there's an attribute that's added to the file saying it's quarantined, so it can't execute. You have to remove that in some way. This is a way in the command line of doing that. So I should be able to write galasactl version. So I've executed the tool properly. It says it's at version 30. So it looks like I've downloaded and installed and used it slightly just to get the version in a few seconds. Now we're going to initialize the local environment, which should allow us to then create test cases and build them. So I've got my galasactl tool. I'm going to local init is the command that I want to run, and I'm going to send the log to the console so I can see what's going to be created. And in this case, you can see it's created a .galasa folder and put some stuff in it. We'll visit that in a minute. It's created an M2 settings XML, which we'll visit in a minute as well. And let's go and have a look at those files. So we have .galasa, which has a bootstrap properties file. We won't be needing that for this demo. You use the bootstrap properties for specifying which server you're going to connect to and where is that server, that kind of thing, if you're talking to the ecosystem server. CPS properties allows you to put properties in here that control the test behavior or control the configuration of the managers or the configuration of the Galasa framework itself. Credentials, if you're talking to a remote system under test, you may want to put user ID passwords in here, so it's more a configuration thing rather than hard coding them in your tests. It's more secure that way, and they won't be checked into source code control. DSS properties is used internally by the framework as it runs to keep track of what resources are being used. Overrides properties is a file you can put, the same as CPS properties, but you can override what's in CPS for particular tests. We won't be using that in this demo, but it's good to know it's there. So also we've got the Galasa boot jar, that is a piece of Java code that it's downloaded in order to boot up the Galasa test running when it runs tests. Also in our environment we've got an M2 now, which has a settings XML file in, which basically says to Maven, when we do a Maven build, how do you contact Maven Central? So we've got the URL there for Maven Central. So I think we're all set up to go to the next stage. So now we're going to show how to create Galasa tests. I'm just going to start a terminal session in VS Code so we can see outputs and edit things easily. Let's create a demo folder, and we'll go into the demo folder. And so Galasa Control has this feature called Project Create. Now it will create material that reflects our problem. So we'll give it a Java package name. So in this case, Galasa, dev Galasa, example, banking. But in your case, it's probably your company name and the project you're working on. I'm going to tell the Galasa Control tool that I'm going to be testing a few things. Now I'm imagining I'm testing a banking application. That's the system I'm trying to test. So it might have a payee function that I'm going to test. It might have an account function I'm going to test. General groupings of functionality, and give them names just to split up what you've got so your test cases aren't all in one big blob. I'm going to want an OBR, I'll explain that later, and I'm going to want to build with Maven. Now I could build with Gradle, in which case it would generate Gradle build artifacts, but I'm going to generate with Maven. And I'm going to have a look at what it's doing in its diagnostics log. I've got that slightly wrong, so let's have a go at features. There we go. And we can see it's created a whole smash of artifacts, and they're all in this file dev Galasa examples banking in demo. So I'll have a quick explore of what we've got. This is one way of creating tests. It just happens to be quite an easy way. It's similar to Maven archetypes if you've come across those before. So here we've got two projects, account and payee, matching the names we gave our features, and we've got an OBR project. So, and firstly we've got a POM which will say it's going to build these submodules, these other projects. So we've got enough infrastructure in here to build everything as well. Let's explore the first test case project. So this has a resource file which just has a string in it, a build file saying how to build it, how is Maven going to build it, and what the dependencies are. And more importantly, I suppose, is the Galasa test case. So this is the simplest test case that it generates. We can see it's a test case because it pulls in Galasa tests and annotates the test class and the test methods that are going to run as part of the Galasa tests. This test itself is just doing something very simple. We've got an annotation here that says this variable is a call manager. Please inject an instance of a call manager into my test. And then the test case itself just asserts that that is non-null. So Galasa itself, it does the injection for you, and you can just call down, declare your dependencies, declare what you want injected. The injection happens, then your test case runs, and you can use whatever's been injected. And we can see this in the more complex, slightly more complex example, the extended example, where we've got a logger and we ask to have a logger injected. We've got some resources, which gives us a way of reading that text file I showed you earlier. I want the name of the test run injected so I can log it. And I want an artifact root, which gives me a folder in which I can store artifacts for posterity, for diagnostics, to see what's going wrong. So first test just asserts everything that was injected, which Galasa will always do. The second test here, it reads the test file that I showed you earlier from this path. This path is relative to the resources. I had this injected, remember, the resources is injected up here, so bundle resources. So I'm reading the contents of that file, and then I'm asserting that they're what I expect them to be. I could log them, I could use them in a test or as test data, whatever. The second example shows that I've got a string that I want to save into a file. So I create a file based on the artifact root that I had injected, based on the run name, and appended with this name to give it a constructed file name. And I can write the file out to the artifact file path and get the bytes from this test message to put into that file. So basically I'm accessing a resource, which is a very common thing to be doing, and writing an archive into a file. I'm not actually calling out to any remote tests yet. I'd have to add that in, but these tests can run without an external system as a dependency, so that's what I'm going to show you today. So we've also got an OBR project with a POM file in it, which says these are the projects that have test cases in them. So when you build the OBR, an OBR is really like an index of what tests are available. So when you launch a test case, you say which OBR it is, and you say which test bundle and test class you want to run, and it can find it from all of the test classes and bundles that are available. So there we are. We've generated our first Galasa project. So now we've generated a Galasa project, I need to build them. Now, when I created these artifacts, I said I wanted a Maven build system. So if I go into the banking folder, I'll have a POM XML. There it is. And if I do Maven clean install, it will pull down all the dependencies I need to build the test and run the test. And it will build the test code that we just looked at, and it will deposit all of the artifacts in the M2 folder. There's the M2 folder in the repository, and if we look in the dev Galasa example banking folder, we can see our built artifacts. So we've got a jar in here somewhere. There it is, with our payee code built. And there's the OBR, which is also a jar. So we've managed to successfully build our Galasa test case. We've got some tests, we've built them, now it's time to run them. So for this we're going to use Galasa control again. Runs submit, so we're going to submit some runs to local. So that's going to cause a test to run on our local JVM on this machine. So let's tell dev Galasa example, let's tell it how to contact the OBR. Example banking.obr, and we'll say which version of the OBR we want. So that version, and it's the OBR. Then we say which class we want. We could have multiple classes here, but let's just invoke one of the tests we created. Example, banking account. That was the test we looked at. Dev Galasa banking. Example. Banking account test account extended. So several things here. We've got the OBR, which is these are the Maven coordinates on how to reach the OBR, and then we've got the bundle for the test class, and then the fully qualified Java test class name itself. There we go. So we submitted the request, and the test ran, and it passed. It was called L3, and the test run ran at those times with that test name. So it's good, it's passed. So what do we have to show for it? Well, in our Galasa we now have this RAS folder, which is a run archive store. For each run we have a folder with the same name as the run name. And we've got the run log, so we can see what Galasa was doing and what the test case was doing. And we've got artifacts that were saved away. Remember, our test case wanted to store a message in an artifact. Well, that's where it appears. So we've successfully run our Galasa test, and we've looked at the results. So we've gone through explaining what the Galasa tool is and why you want to use it, what it does. We've prepared our environment, downloaded and installed the Galasa control tool. We've initialized our local environment to set the scene for creating Galasa tests. We generated some very simple tests that don't do a lot, but it's a good jumping off point. We built those tests, we ran them, and we looked at the test results. So that's a brief run through. I say brief. It's a run through of the Galasa control tool and what you can do with it. I hope it proves useful. Any comments would be great, either by email, Slack, or comments on the video itself. Thanks for watching. Bye for now.